All right, so this was a question which was testing your theoretical understanding of the confidence interval, and you're given, 3a, and you have to calculate, um, and at a 92% confidence interval, that's not an issue that you can do. But part B was a little interesting. So it says here that the researcher used three random samples, and he calculated three independent 92% confidence intervals. And you have to find the probability that all three of these confidence intervals contain only values that are greater than the actual population mean. To understand what's going on here, you first have to understand what confidence intervals are. When we go from our sample to our population, right? We obviously used unbiased estimators to get us to get our mean and our variance there. The confidence interval is basically gives you a particular interval for the mean, and the need for this is because of the fact that since you're estimating the mean, if you were 100% sure that whatever the mean is of the sample, that'll be the mean of the population, you wouldn't need a confidence interval. But because this, again, as the name suggests, you're using unbiased estimators, this is an estimate, you want an interval. And what does a 92% interval mean? A 92% interval means that within this interval, if I did this estimation, let's say 100 times, then 92 times out of 100, let's say, my population mean would be within the particular interval. So if I had a 95% confidence interval, that would mean that 95 times out of like 95 particular samples out of 100 would have their mean within that particular interval. So that's the basic idea. Now, if you look at it here, I'll just show you through a normal distribution curve. If like this, if these are your two intervals, and like this is like 0.92, then it should go without saying that this should be 0.04, and this particular area should be 0.04. So like so the probability of being, like, let's say, above the interval, above the interval where it was where we could say with a certain degree of confidence that our mean would lie. So above this acceptable interval, the probability for one sample is 0.04. So again, for one sample. Right? Because again, if you took 100 such samples, then 92 out of 100 times, it would be within the range. 4 out of 100 times, it would be below the range. It would be below what you can call your actual mean, actual population mean. And 4 out of 100 times, it would be above your actual population mean. You want to do this for 3, so you want it to be above for like the first random sample, and for the second random sample, and for the third random sample. When you're using and, you use multiply. If it doesn't logically make sense to you, you can just remember it like that. So, and the probability of being above the sample is the same for each, right? You're just using 3 random samples. There's no difference in any of them. So it has to be above the sample in one, and in the second, and in the third. You can just write this as 0.04 Q. And then you pop it into your calculator and you get your value. I don't have my calculator with me right now, but you get the idea, right? And that was it for this particular question.